In this problem, we have a passenger plane A that's flying east with a velocity of 620 kilometers per hour when a smaller aircraft B passes underneath, heading southeast in the direction shown. The passengers in plane A, however, see plane B flying sideways and moving due south. Determine the actual velocity of plane B and the velocity of plane B as it appears relative to the passengers in plane A. All right, so there's a lot going on in this problem statement. The key to solving relative velocity problems is to make sure initially you know what is absolute and what is relative. So in the problem statement, it says that the plane A is flying east with a velocity of 620 kilometers per hour. So that's absolute. So we're going to write that as V sub A. And then we have plane B, and the problem statement gives us an actual direction of its flight and a relative direction of its flight. So plane B passes under plane A heading southeast, so that's absolute. But then it says it appears to the passengers in plane A that B is flying due south, so that's relative. So we can say that the velocity of B relative to A is in the south direction. And then we want to find the velocity of B and the velocity of B relative to A. All right. So drawing a figure is always a good idea. With the relative velocity problems, you want to draw the figure, include all the velocities and a coordinate system. The relative velocity equation is a vector equation, so we need a coordinate system to go with that. And then we'll relate all of those velocities through the relative velocity equation. All right, so here's our figure. We have plane A, which is traveling due east, but we're going to call that the y direction. And then we have plane B, which is traveling southeast, but we're going to give the south direction the x coordinate. And then we know that the angle is 45 degrees, so we can decompose this into the x and the y direction. And then the relative velocity is due south, or in the x direction. So we'll write all of those velocities in vector form. So we have VA, VB, VB relative to A. Now notice when there's not a value given, we're just going to use a variable. So VB, we don't know the magnitude of VB, but we know its direction, so we put that in. And the velocity of B relative to A, we don't know the magnitude, but we know the direction. All right, and then we use the relative velocity equation. So VB relative to A equals VB minus VA. And we just plug in all what we know. Okay, so we have this one equation, but we have what appears to be two unknowns, the velocity of B relative to A and the velocity of B, both of those magnitudes. How do we solve this problem? It's one equation and two unknowns. Well, it's a vector equation, so it's not really one equation, it's two equations. We have an equation in the I, and we have an equation in the J. So all we have to do is separate out those components. So now we have two equations and two unknowns, and that's easy to solve for. So we solve for the magnitudes, and then we plug it back in to get the vector.